All right, good morning. Welcome to Trig Review. So trig ratios, right? Trigonomic ratios are ratios of the lengths of the sides of a right triangle. These ratios are called sine, cosine, and tangent. Each ratio describes the relationship between a non-right angle and two sides of the right triangle. For an acute angle in the right triangle, so again, we're always working with acute angles. We're never working with the right angle, so it's the non-right angle. For an acute angle in a right triangle, the adjacent leg is the leg that forms one side of the angle. So let's talk about that. So if I'm drawing an angle, I have two rays that make up this angle. So these are adjacent to this angle. All right. Then it says that the opposite leg, the opposite leg is across from the angle. It's the one that does not touch the angle. So if I were going to form this into a triangle, the opposite leg would be the blue one from this angle. And then across from the right angle, again, that's always our hypotenuse. Okay. The hypotenuse is the longest side of the right triangle, and it's opposite the right angle. The triangle shown below, right, has length A opposite angle A, and length B opposite angle B, or adjacent to angle A. And then they called C the hypotenuse. Excuse me. The sine, cosine, and tangent ratios are defined as the ratios of the side lengths of the right angle. So for sine, it's opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And so we have a little phrase that we say that helps us to remember, which is called SOHCAHTOA. So in this picture, I guess I'll do it with the pen. So if I'm looking at angle A, which is the angle that they want me to work with, angle A is right here. So opposite from angle A is the one that does not touch it. There's opposite. Adjacent, right? We have two adjacent sides, but this side has got a special name. It's across from the right angle. So this side is our hypotenuse. And so the other side that touches A must be the adjacent side. And so that is why they said opposite over hypotenuse. Hypotenuse is A over C. Opposite over hypotenuse, A over C, and so on and so forth. All right, so example A. Find the sine, cosine, and tangent of angle X. So angle X, we're dealing with this angle right here. So I'm going to identify first. These are my two adjacent sides. So one of these is the adjacent, and one of them will be the hypotenuse. Here's my right angle, so my hypotenuse will be across from it. This will be my hypotenuse. That makes this side that touches the angle the adjacent side, and it makes the side across from it the opposite side. And so since the lengths are 3 and 4 and 5, if they wanted sine of x would be opposite, which is 3 over hypotenuse, which is 5, 3 over 5. Cosine of x would be adjacent over hypotenuse, so that would be 4 over 5, 4 over 5. And tangent of x would be opposite, 3 over adjacent, 4, 3 over 4. And they may ask you for it as a ratio or a decimal. And in this case, they're leaving it as a ratio or a fraction. All right, moving along to the next page. Guided practice. The length of the side of the adjacent adjacent to angle D is, so here's angle D. The length of the side adjacent to it would be right here, adjacent. Again, it has to be either this side or this side to be adjacent. And this side is the hypotenuse. And so the adjacent side would be 12. The length of the side opposite D, opposite would be not touching D. That's the third side over here, 5. And the length of the hypotenuse is 13. By the way, these numbers, 5, 12, 13, and the previous example where we had 3, 4, 5, these are called Pythagorean triples. And a Pythagorean triple is 3 whole numbers that work in the Pythagorean theorem. So a squared plus b squared, we're checking, does that equal c squared? Oh, I think I was off the page. I don't think you could see what I was doing. Oh no. I'm sorry, I'm going to repeat that, guys. Okay. Sometimes I don't realize that my camera is off the page. I apologize. So I'll repeat what I said. So I said, okay, here's angle D, and I highlighted the angle. One of these will be adjacent, and one of them will be the hypotenuse. So first I'll identify the hypotenuse. To do that, I'll find my right angle. Right across from it will be my hypotenuse. That means that the other side that forms angle D must be the adjacent, and the side across from it must be the opposite. All right, and then a Pythagorean triple, there are 3 whole numbers that work in the Pythagorean theorem, and you can see that when I multiply these and add, so I square and add, I get 9 plus 16 equals 25, which is true. 9 plus 16 is 25. And the same thing with the next one. If I square these, 5 squared plus 12 squared, does that equal 13 squared? 25 plus 144 equals 169, and yes, that is true as well. All right, moving on. Find each trig ratio. So again, we're working with angle D. Now, if we were working with angle E, what would happen here is that if I was at angle D, this is opposite and this is adjacent. But if I were over here at angle E, these two would flip-flop, because now adjacent would be touching angle E. The hypotenuse would still be the hypotenuse, but across from angle E or opposite would be adjacent. would be this one, 12. All right, so opposite over hypotenuse would be 5 over 13. Adjacent over hypotenuse would be 12 over 13. And opposite over adjacent would be 5 over 12. In right triangle JKL, okay, so I'm going to draw a right triangle. It says the leg opposite of angle K is 3 units long and the hypotenuse is square root 10. So right here, my hypotenuse is going to be square root 10. And K has to be one of my acute angles. And the reason that K has to be acute is because they ask us to find tangent of K, and we cannot work with the right angle. So I'll call this K. And so it says the leg opposite of angle K. So opposite of angle K would be across from it over here at 3. All right. So it says first identify the side opposite of angle K. So the side opposite of angle K is 3 units. And then it says use the Pythagorean theorem to find the length of the adjacent side. So we're missing this side, and we're going to call it B. And so we say a squared, which is 3, plus b squared equals c squared, which is square root 10. Now always the hypotenuse must be c. Always. So that means that b squared equals, this is 9, And square roots and squares are inverses, so this is 10. Whoops. I've written them in the wrong order. I apologize. Let me get my white out. They're skipping a step, so I'm going to show that step off to the side. I'd have 3 squared, which is 9, plus b squared equals square root 10 squared. Square root 10 and the square root and the square cancel, so I have 9 plus b squared equals 10, and then I would subtract 9 from both sides. And so b squared equals 10 minus 9, and 10 minus 9 is 1. And then the square root of 1 is 1. And so the adjacent side is 1 unit. Now I can write the tangent ratio for k. So tangent k, tangent is opposite over adjacent. Opposite of k would be 3. Adjacent would be 1. All right, guys, you have some independent practice. As you can see, numbers 1 through 6. And then also on the back, you have numbers 7 through 12. We have one more example to go through. So example B, it says trig ratios can be written in simplest form. So it says to find sine, cosine, and tangent of angle G. So I'm going to be working with angle G, which is right here. So let's first identify our opposite, adjacent, and hypotenuse. So here's angle G. Touching angle G are these two sides. This side is called the hypotenuse because it's across from the right angle. This side is called the adjacent. And then this must be our opposite. It is across, not touching the angle. So sine G is opposite over hypotenuse. So that would be 4 over 2 root 5. All right, now we cannot leave a radical in the denominator, so we're going to simplify by multiplying both the top and bottom by whatever this radical is. So they multiply by square root 5 to both. They're skipping a step right here, so I'm going to add it in. So I have 4 over 2 root 5 times square root 5 over square root 5. So this is 4 square root 5 over 2 times the square root of 25. The square root of 25 is 5, so I have 4 square root 5 over 2 times the square root of 25 is 5, and that's where this 10 came from. Now I saw many of you make this error on the simplifying, or not simplifying radicals, the 30, 60, 90, and 45, 45, 90 triangles. A lot of you guys went like this and canceled this direction under a radical, and you cannot do that. And then the last step is that 2 will go into both of these. 2 goes into 4 twice, and 2 goes into 10 5 times. And so that's 2 root 5 over 5. All right, next one. Step 3, to find cosine of G. So cosine of G, cosine is adjacent over hypotenuse. So adjacent would be 2 over hypotenuse, which would be 5 square root 5. This is an error right here. This is not 5 square root 5. There's a typo. This should be 2 square root 5. All right. And so again, they're skipping a step right here, so I'm going to show it. They have to rationalize the denominator, so they multiply by square root 5 over square root 5. But they have 2 square root 5 over 2 times square root 25, because square root 5 times square root 5 is square root 25, which is, these will reduce. I'm going to go ahead and reduce those. So that would be square root 5 over the square root of 25 is 5. All right, and then the last one is tangent. So tangent is opposite over adjacent. Opposite over adjacent would be 4 over 2. 4 over 2 reduces to 2. All right, guys, that's it. I hope that you are fine with these notes. If you need anything, please jump into Zoom tomorrow, and I will see you on Monday for certain. Bye-bye.